systems. So that is what we're talking about. With his support, we had done that particular work, a similar job also for our PhD student Sashwat, where he took up energy harvesting in addition to SBD parts, security by design. So thank you, Dr. Mohanty, for agreeing to be with us. Now let Ayas read out, and after that we will request Dr. Mohanty to deliver his lecture.
Okay, thank you, Mahapatra sir. I feel honored to introduce today's speaker at Atal FDP for Hardware Internet for Internet of Things, Dr. Saraju P. Mahanti sir. Dr. Saraju P. Mahanti is a professor at the University of North Texas. Professor Mahanti's research is in smart electronic systems, which has been funded by NSF, SRC, US Air Force, IUSSTF, and Mission Innovation. He has over 20 years of research experience on security and protection of media, hardware, and system. He introduced the Secure Digital Camera SDC in 2004 with built-in security features designed using hardware-assisted security or security by design SBD principle. He is widely credited as the designer for the fast digital watermarking chip in 2004 and fast the low power digital watermarking chip in 2006. He has authored 450 research articles, 5 books, and 9 granted and pending patents. His Google Scholar H index is 47 and I-10 index is 203 with 10,400 citations. He is a recipient of 14 Best Paper Awards, Fulbright Specialist Award in 2020, IEEE Consumer Electronics Society Outstanding Service Award in 2020, the IEEE CS TCVLSI Distinguished Leadership Award in 2018, and the PROS Award for Best Textbook in Physical Science and Mathematics category in 2016. He has delivered 18 keynotes and served as 14 panels at various international conferences. He has been serving on the editorial board of several peer-reviewed international journals, including IEEE Transactions on Big Data, IEEE Transactions on CAD, as well as EIC of IEEE Consumer Electronics magazine. He served as the chair of the IEEE CS Technical Committee on VLSI TCVLSI during 2014 to 2018 and served on the Board of Governors of the IEEE Consumer Electronics Society during 2019 to 2021. He is the steering committee chair or vice chair for the IEEE International Symposium on Smart Electronic Systems ISCS, the IEEE CS Symposium on VLSI ISVLSI, and the OITS International Conference on Information Technology OCIT. He has mentored 3 postdoctoral researchers and supervised 14 PhD dissertations, 26 MS theses, and 18 undergraduate projects. So I feel very happy to introduce sir to our audience or participants. So I request sir, already sir has shared his slide. So I request sir to start his presentation.
Okay, thank you, Professor Mahapatra, Professor Swami, for the kind introduction and for the opportunity. So for the audience, like I have a lot of slides, so don't be overwhelmed. What I will do, I will have around 1 hour on the slides technical aspect, which is security by design. And then we'll spend some time on what is the good best practice for research, because I see this is a faculty development program. This is not a keynote or a conference keynote like situation. So I really want to discuss with you what is that it takes to be a very good researcher. Meaning I see when I'm working with so many students from India, junior faculty from India, that the works are very good. You have done quite a bit of technical implementation, and there are really, in many cases, fabricated chips are there. But still, there are difficulties in getting those accepted in high quality venues. So I want to share some of the experiences, okay, how you should take up the research, then from go with a route where you are first publishing a conference paper and then you are publishing a journal, or you are first releasing a preprint in archive-like venue and then publishing a journal. So we'll spend around 30 minutes, but first 1 hour is technicalities. So a lot of slides. Please feel free to whatever you can. We'll spend time. It's not maybe 50 or 100 slides, but feel free to download and see what are the research scopes. Okay. Anyway, and the scope of this presentation, and which is a very big theme that I made, is how physical unclonable function is helping to do a new security paradigm, which is security by design, and which is essentially helping to secure not just data, which is worldwide, everybody is doing network, tons of things are there. I don't care for those. I am interested more on the device and the system aspect. Okay, and I consider these are much more difficult problems than having a password with the 256-bit and those kind of security, which everybody is doing, and network communication community are plenty. Publication-wise, they are doing quite a bit. But difficult problem is to secure the device, is to secure the system. And I always tell why security problem, even though last 20 years or so, lot of research has been done. Why security problem has not been solved? Because hardware people have not worked on it. Very simple. Once the hardware people start working, security problem is solved. And it is late, but last 10 years at least, I'm seeing hardware people have started paying attention to the security research. And once the maturity of research happens in the hardware security, then only system will be secure. So it's a very big concept, and a lot of very good thing can happen, particularly because US government right now putting roughly $50 billion on semiconductor industry. India is putting roughly $30 billion on semiconductor industry. And there are all of a sudden a lot of jobs in hardware, but trained manpower are not there. So if you are on the market with a hardware PhD, hardware masters, lot of jobs. Okay, but a lot of people think data science has a lot of jobs. Okay, anyway, so that's the background. Okay, and with this is a little bit always social need to drive research. Okay, not just like the technical or academic point of view. So there is a need for social need, and there are plenty of examples like that. And as a result, these concepts like smart city, smart village, all these things we are promoting. And what are the key aspects of smart city, smart village? Are the connectivity, sensors, AI, and so on. But all these are essential hardware. Okay, you don't do data without a hardware. Hardware is storing, whether it's a simple USB that you are using on a daily basis or a cloud storage, OneDrive or Dropbox, whatever, everywhere there is a underneath hardware. Okay, so hardware is an independent entity which is storing a lot of data, and those needs to be secure. Okay, and a lot of data and so on, what we deal with in the context of smart city. And examples, let's say smart healthcare, one example, and other components of that, they need to be secure. Okay, so system and device security aspect we will deal with. So these contradictory, what you can say, concept, smart city essentially goes with assumption that people are moving to city and overwhelming population is there. So a lot of hardware, software infrastructure, of course, civil infrastructure, and so on. And then at the same time, another concept, smart village, where the idea is with minimal hardware, what we can provide to them. Okay, even healthcare is a problem which is there in village as well as city. City people also eat food, okay, but agriculture happens in villages. So we have to have, so these things if you keep in perspective. So for smart city, smart village with components, healthcare, agriculture, and so on, transportation is a city problem, it's not a village problem. So like that have to be there. Okay, and underneath of all these is what we call cyber physical system or Internet of Things. Okay, and when we compare these two system concepts, smart city or smart village, smart city obviously have variety of CPS as a result, variety of IoT structures. Then one can afford to put more money, so design operation cost can be high. Smart village, on the other hand, we cannot have a lot of budget, okay, because population is low, people pay less tax, and as a result, we cannot have massive infrastructure. So if we see this, what kind of hardware software that city can afford? Quite a bit. May have a lot of cloud infrastructure with high bandwidth internet. As a result, we can do big data AI and so on. On the other hand, smart cities may not have cloud, because if cloud are far away from the village, obviously, and we may not have internet all the time, good bandwidth internet. We may not even have good power supply. There may be power failure, okay, and scheduled on-scheduled power cuts are there. So this situation clearly tells, okay, is IoT basically computing can be beneficial for smart cities. Okay, so IoT edge and corresponding computing, lightweight machine learning model and so on, low cost hardware and so on are important for villages. Okay, on the other hand, city people, as I said, can have cloud and so on. So this is the thinking. Okay, so then when we are tuning, as we are engineers, okay, tuning our hardware research and so on, okay, probably we'll assume city-wise IoT cloud, whatever hardware, software, security, that is heavy duty, okay, because high bandwidth people can attack easily. On the other hand, village, low bandwidth, maybe some low sigfox like connection, which is just some Mbps connections, and then power failure may be there. So somebody, let us say, having some smart healthcare infrastructure and power failure for a day, then one cannot charge his or her oxygen tank. So that kind of situation one has to think. So these are, that's a, both are very challenging process. It's challenging actually for research point of view, system of systems, both are challenging. Both constraints are different. Okay, that's why it's interesting, and that's why when I talk to students, I ask what they want to do, and then we formulate problems according. And problems are plenty available, and we can discuss more offline. Then these 3 I's, what I call, that is instrumentation, intelligence, and interconnection. These 3 I's are needed, whether you call it a CPS or IoT, we have to solve, and hardware, software, both there, and but hardware is an independent entity that will deal with the software. So IoT and CPS, 2 concepts which are basically used by different community. They may be same, they may be different depending on how we perceive. Okay, IoT, this is infrastructure we saw. If we see CPS, CPS has 3 C's I call, and IoT has 3 I's. That is how they differ in terms of that, but essentially they're the same. That is some kind of computation, some kind of communication, and other things are there. So anyway, so at the end, they will be made by hardware, software that we are thinking of design. But if I correlate this is a very interesting slide. Just recently, I was on a panel at IFIP IoT conference in Amsterdam in November, full IoT community. And I asked a few people, okay, what is the difference between IoT and CPS? Okay, and everybody had, okay, it's a difficult question. So anyway, but I have clarified this in 2016. Okay, so IoT is the connectivity of the devices other than computer. If computer is connected, then it's IT infrastructure. Okay, it is a network. On the other hand, something other than computer, when connected to internet, became IoT, Internet of Things. Internet originally is Internet of Computers. Okay. Then when these IoT are deployed in physical entities, like you deploy in a home, it's a smart home, that is a cyber physical system. You deploy in hospital, it's a smart hospital, that is a cyber physical system. You put on the bridge to monitor a bridge health, okay, civil infrastructure, that's a CPS. That is how things are different. Okay, anyway, but computation point of view, they are essentially same thing. Okay, anyway, so now for the healthcare, if you see the infrastructure, similarly, we can see for agriculture and so on, all these, okay, all these are similar thing. There have to be end devices or things or whatever we call it. There have to be edge devices, which are close to the user, but they are not end device. Okay, they are edge device. Okay, that means they are close to the LAN. Okay, it's close to the user, therefore not as far as like cloud, but they are also not end device. Okay, end device like phone is a very tricky situation, whether you call it edge device or end device. But in general, what we can say, something like wearable, this and that, we can consider as end device. And then edge device close to the LAN. Then the further things are what is that, cloud and so on. That is how we can conceptualize. Okay, and then in some cases, in the local area and wide area together, they can work to basically take advantage of reasonably computational facilities available. They can do something called collaborative edge computing. This is a very interesting research. Okay, collaborative edge computing. They are basically, let's say, 2-3 villages. Okay, Rourkela nearby, 2-3 villages. Let's say they have low scale computing. They want to work together to do some reasonably big data without using cloud server. Okay, so that kind of scenario is collaborative edge computing, which is a new research area. Few people have worked, and one of my students is trying to do its security paradigm, of course, using POF and blockchain. So that's a very interesting area in edge computing. So IoT cloud, a lot of people say IoT cloud is kind of outdated research. Okay, it started roughly 20 years ago. And around, let us say 10 years ago, edge computing started, or for some people call it fog computing. And now it's catching up. Then the advanced concept in the edge IoT is the collaborative edge computing. So that is an interesting area if you want to work. And I feel that has a lot of application in smart village context. And that's why I have basically one student allocated to look into that. Okay, and this is a very interesting research that very good work. Triple and Naraipur people have been helping them the last few years. So what I know, actually undergraduate students did this implementation. Amazing. They really built this device. Okay, and we published in IEEE Sensor Journal. Okay, and this is a system that is field tested for roughly 6 months. Okay, and it's working. It has a lot of capabilities, that is auto detecting the crop damage and so on. Okay, that means throughout, let's say 6 months, it stays on the field and continuously takes pictures, and then determines what kind of damage is happening because of maybe environmental or because of disease and so on. And then that assessment can be done, and farmers can be warned, okay, that things are going wrong, please do, let's say, fertilize or call a horticulturist or whatever, those kind of help one can get. And this is very good work. And in this domain, okay, how to handle security and so on is an interesting area, because this security have to be lightweight. Okay, you cannot have overhead on the system because you are using a security mechanism. So this is a very interesting problem to work on. And this transportation cyber physical system is another CPS. This is also interesting problem. This need not be because now EV, this and that, people are trying. This need not be energy or resource constraint point with that much the problem. But what is the problem here? The security solution have to have low latency. Okay, why low latency? Because it's a matter of time when something is happening and you have to put a brake. Let us say your car has to take left turn, your autonomous vehicle, and by mistake it took a right turn. Okay, so that difference or that correction has to happen in a millisecond. So that is why, even though energy point of view, this is not a big problem for transportation, but the latency point of view, it's a big problem. That is the same security problem. Depending on the type of cyber physical system, the constraints vary. It's a latency constraint problem. Agriculture, I was saying energy, healthcare is further energy constraint problem. Okay, anyway. So like that is very interesting. I have not done much work. Few papers I published because people wanted my help with POF and with blockchain. But this anybody interested, they can. But I like more on healthcare and agriculture. And energy, another big, this is everything. Without energy, we won't be talking right now, or nothing would be there. Okay, so this is again a big problem. And having security mechanism on the energy is not an energy constant problem, because it's power, right? Transmission network and so on. But that itself becomes a disadvantage. These are massive infrastructures. Okay, and if somebody breaks, right now, in fact, in US, there are some state that is a lot of transformer at a time basically broke. Okay, so there is investigation whether it was intentional or unintentional. So that's why energy infrastructure, which relies on old-fashioned SCADA, is the software that is done for the management of the energy infrastructure that has a lot of what you can say loopholes, security point, because it was not originally meant. Okay. Similarly, in the transportation CAN bus, originally the way it was done, nobody thought it will be a security problem. So those are wide open. So a lot of changes has to happen. And here SCADA system, so on in the energy infrastructure. And here the problem, as I said, energy are plenty available. Even if the security you provide, continuously one can attack. Okay, because things are always online. Okay, so this problem you have to have such a way that heavy duty security some way has to be done so that people, while hitting with a lot of brute force encryption keys, cannot break it. Okay, and in the when actual quantum computing and so on comes, any type of security put anybody can break. So that's why this problem domains are totally different. As I was just saying, healthcare same security problem, different in healthcare, different transportation, and different in the energy. And this is a very difficult and but social impact point of view amazing. That is why with Professor KKM, he is just a student graduate last year, Shashwat, that eternal thing concept we developed. That's an amazing concept. So that means you essentially think about security right when we are designing the sensor. Okay, then when you are designing the system and so on, at every time, how to have additional features which can be used potentially for security purposes. That is the idea of security by design, essentially, to put in a simplistic way. Anyway, so a lot of things and industrial IoT can happen. Anyway, so when these IoT and CPS are done, okay, a lot of problem. This is actually a subset of a lot of things that people have published. Okay, for example, number of sensors. Okay, number of things are quite a bit. Then design operation cost is now like a city, village, healthcare, this and that point of view, how they are different, and accordingly the problem scope changes and what kind of solution can be provided changes. Then security, privacy, IP protection, all these are valid problems. It is not a same word. Privacy is not same as security. IP protection is not same as security, but they are related. Okay, and then at the end, we need to make all these things we are making, which are connected, which are smart. Those are done by some data gathered and a model developed, and then decisions are taken based on those information. So it's all these we are taken into account. Then architecture dependency. When we have a lot of things, a lot of edge devices and so on, maybe let us say human population is roughly 8 billion by 2045 or something people are predicting. So if 8 billion population and per household, let us say 2, 3, 4 phones and 2 cars and so on altogether, imagine the number of and the TV, all these are now connected to the internet. So whether the current that internet protocol address the way the network infrastructure that will support, that's why there is people those are working that domain, and they have to worry about that. So they are basically architecture and dependency. That is how all those are connected and how one sensor after another basically able to process the data. All these are come under that domain. And energy consumption, okay, is a big deal. It has been a big deal even though last, as far as I know, 30 years people are solving that problem, but that problem still remains because it is a difficult problem. Okay, in fact, when I was doing my PhD, that is low power digital hardware in 2000. So then I was doing literature search. I felt that was 20 years old problem. Now already 20 years, rather 23 years have passed. So that is, imagine 40 years. Okay, but still our pure digital, let us say this our smart mobile phone, but still we charge our phone almost every day. Okay, not like charge a phone once and it works for a week or so. So still long way to go. Okay, and of course, as hardware people, we know technology scaling so on has helped quite a bit. And maybe next 3 years we'll have 1.5 nanometer. Intel is trying, and I'm sure Samsung, TSMC, all these are trying. Samsung this year 3 nanometer. All around get that device is the best technology available, but full-blown chip design out of that I haven't seen, but maybe in a year or so it will come. So my prediction in 3 to 5 years we'll have 1.5 nanometer from all these companies like Intel, Samsung, as well as TSMC. So it solves quite a bit of energy problem. That is why we have these mobile phones what we have. Otherwise, when Motorola did this mobile phone, maybe around 40 years ago, it used to be huge, and they used to call it brick. It's like big brick, the way those brick you can comprehend what we used to make our houses. Okay, those huge and a lot of basically electronics inside that, and I used to obviously battery hungry. But to compare to that, we have done amazing, but still long way to go. And that is how I comprehend the problem. If I charge my phone every day, then I don't have a good low power design. It's as simple as that. Anyway, so that problem is there and will be there. And then safety, obviously. Okay, and what we really think always, okay, electronics is doing amazing, hardware, software, all this together. But what is the problem of any of these electronic things that we deal with is the lithium-ion battery. Okay, battery technology is not progressing, okay, as it is supposed to be to cope up with the energy demand, energy, not just the amount of energy, also the energy delivery, how fast the energy should be delivered to the system, let us say to an electric car or to a smartphone and so on. So a lot of charging, discharging all these times, okay, there, and how long it can last depending on the ampere hour capacity and so on. All these are problems. So we are stuck with lithium-ion battery. And I remember when I was doing my PhD, that is, I did a course, MEMS, microelectromechanical system, that was 2001 or so. And so again, 20 years passed, and we have been thinking, though, from those days, we'll have alternative battery. Okay, we'll have, for example, maybe nuclear battery, maybe from the, what is that? I forgot that one. Breaking the water and having that battery, I forgot that one. So like that, few batteries that I very well remember, nuclear battery and so on, people are talking. And but where are the technology? Nothing came. We are stuck with lithium ion. Okay, so that is a problem. Okay, lithium ion, when current demand is high ampere rating, then it's a safety problem. That is the reality, but still we have done what we have done, amazing. Anyway, so that problem, that is why relates to, I was mentioning eternal thing that Professor Kekem and student did, has quite a bit of significance. What is the keyword? There is the harvesting. Okay, so energy harvesting along with security, that together is a key point. So anybody is doing, let's say, Praganjit is working on, I think, or so, or, sorry, in slide or B slide, whatever those two papers, right, we just discussed. Security aspect adding is a very important point. Okay, so energy harvesting security motivation is to have built-in mechanism security, and then energy harvesting because battery is unsafe. Okay, that's the motivation. Okay, and then what is the important application I see? For example, let us say in the city applications, okay, let's say park or even tsunami like warning system that is going to the deep sea and so on. So if we have very good sensors that can harvest the energy, then the maintenance requirement will be reduced significantly, and we'll have built security mechanism. So there are very important applications. Lithium ion being unsafe, and the what you can frequency at which they need maintenance motivates us to do more on energy harvesting aspect as well as security. Okay, that's the key point. Safety is a big, and robustness obviously, and many more are there. Okay, and we can discuss this as this slide itself. I'm slide 16 only. Okay, anyway, so a lot of things we discuss. I can skip a little bit in the interest of time, and all you can go through. Okay, how that's why when we are doing the security research, what is important is to know what is the threat model we are addressing. We cannot solve all the problems. Okay, so security wise, if we see a lot of variety of security problem, and we cannot solve. So in a specific manuscript, a specific paper, it's a good idea that's upfront to tell the reviewer that this is my security model or security threat. Okay, so I'm handling either eavesdropping or access control or whatever, and then accordingly, what is my solution? So threat model analysis is very important. And this slide, let me spend few minutes. Here, system security is what I'm saying. If you see data security aspect, I'm not talking about at all. So power grid security is a big deal. Okay, many issues have been there. Many news plus I have seen how people are able to attack power grid and power station and so on. So these are scary because they can black out a complete city or a complete state and so on, or maybe a full grid. So this is a problem. And this car, again, a lot of research is going on to have autonomous vehicles. And autonomous vehicles major bottleneck is again hardware. To have level 5 autonomy, that means fully autonomous, we need to have all the computations. That means the sensors coming from light and so on, all these lidar, whatever, video, all these have to be processed, and a decision has to be taken in the range of millisecond. And to have the kind of hardware that is needed is a challenge. NVIDIA claims some hardware. I remember 2019 or 2020 probably, January, when I was in the CISO. So it's the Consumer Electronics Show every year, January, happens in Las Vegas. I have been going last 5 years or so continuously. I went and there. Now I'm bored because I don't see a lot more innovation. Okay, so there is to innovation to see. But one innovation last I had seen, that is 2020 January, is NVIDIA hardware, and they claim they are doing a huge, that number was probably 100 teraflops per second, something like that. But still, people said that is not sufficient computation for a level 5 autonomy. Okay, so that means the amount of processing needed for the car to real time do everything, and that is millisecond range in the, because imagine a human brain, when we see somebody as a driver, we see somebody came to the front, the moment brain immediately triggers and we put the brake. So that kind of that is coming data, making a decision, and then doing a basically actuation. Okay, that is sensor, processing of sensor data plus a actuator. That combination feedback loop has to happen in millisecond, which is still a difficult problem. So then security on that is a further difficult problem. And here I have a drone. Drones are used mostly military purposes we are seeing, but they have very good use in agriculture domain. Okay, particularly I see people putting what is that fertilizers and so on using drone. Okay, and amazing. It's a very interesting innovation. And in fact, Amazon was trying to home delivery a lot of things through drone. So probably it will happen. It's a matter of getting the what you can say regulation, this and that, whatever needed to get them approved. But it's amazing device that will work. So its security is further challenging. Why it is challenging? Because drone is typically much faster than cars. Like it's flying. Okay, so if in the car we have millisecond like a type of latency, imagine drone, what will the latency? It's further less, maybe in the latency of 0.01 millisecond. So that's why having security mechanism is a very difficult problem. And this figure I borrowed from somewhere, that website, and that website essentially ad was one could hack a military grade UAV for a $25 device, using a $25 device. So that is a very scary situation. So anyway, so this problem is that means UAV security that can be real time is a very difficult problem, and anybody interested, feel free to work. That will be really you'll get a lot of impact. As I said, this one, and I have been doing both medical and agriculture. A lot of things can be done there, and important, as I said, is to figure out in each case what is the threat model, and then what is the solution we are proposing. And all these systems that we saw definitely are energy efficient, energy constant as well as latency constant. Probably rather in the healthcare, latency constant can be is okay, because let us say your security because of blockchain use or because of POP use is taking a second. It's not a big deal. Okay, because these applications, particularly healthcare and agriculture, I said, but transportation, UAV like situation, it's millisecond. So latency constraints are much more. And in healthcare, agriculture, energy constraints are much more. That is how the problems are different. But UAV, energy constraints are also important because UAV battery driven has a range limitation. At the same time, it has latency constraints. That is most difficult scenario to handle. Okay, if anybody interested, and always I'll recommend handle difficult problem. And if you provide a reasonable solution of difficult problem, your chances of getting papers accepted and getting visibility is much higher. This is a medical device. We have done a lot of solutions, and these are definitely connected. Even though in this slide, what I'm trying to tell, FDA is federal government agency that have a lot of observation about these devices, and they have issued a lot of warnings how things are not right. Anyway, and that situation can be there also in the IoT, that is Internet of Everything domain, where like energy constant can be there, and also the latency constant because of the bandwidth rather can be there. And again, federal government has issued a lot of warnings that what is going on when you do smart agriculture. This is a lot of warnings on the smart healthcare domain and so on. So those problems are actually real. And then, so in the smart agriculture domain, again, variety of security problems are there, and they need solutions which are small size, compact, and under the assumption will not have computational resource to run encryption like protection. And here, this is very scary situation. Here, what is the problem in the smart autonomous vehicle? If somebody able to manipulate this signal, that means signal after the AI happening, AI model and so on, actuation, actuator, whatever signal they receive, if somebody can manipulate that, then you cannot protect that system. Now that's a very difficult situation, security situation is there. And what do you do with it? That is your problem. And that problem, if can be solved, you will have very good publications accepted on this domain. So that means you are doing sensor security or actuator security, whatever you call it, right at the last phase of that sensor actuator feedback loop. That means, let us say, because of visual, because of video, because of leader, whatever, okay, all these, the decision is taken, put the brake in 1 millisecond. But somebody, actuator, manipulate the actuator signal, so put the brake, becomes take a left turn or even becomes speed up, okay, accelerate instead of decelerate. So as a result, there can be serious consequences. So this is a very important problem if somebody wants to deal with. Okay. Anyway, this we have a lot of discussions, and this RFID other things are there because they are used plentifully. Anyway, so all these problems are there. Then another interesting thing I always tell, the motivation, why we have to do what we are doing. Okay, so motivation point of view, any device that is not built in hardware security and so on, okay, and not legitimate is susceptible to the hacking mechanism that is continuously going on throughout the planet. If you are connected, you are subject to some sort of hacking. So that is why all these are problems. And this is a very nice, simple slide, how AI or smart devices that we are talking all the day, okay, can be really made to hack in very simplistic. Let us say somebody wants to create a problem. So during the machine learning model development, whatever, AI or whatever, the data labeling somewhere just changed, where stop signal is labeled as a speed limit signal. Okay, this is a classic example everybody shows. So that minor change in the tagging of the data can completely skew the model. As a result, when the car should be putting the brake, it will declare that a speed limit of some number. Okay, that means car is not putting brake, it's not coming to stand still, it is still keep on driving. And as a result, you have a serious consequences. So this is considered as a simple example of how minor problems can cause serious consequences. Okay, and in healthcare domain, you have similar situations one can think of. Okay, that is a wrong diagnosis that means a model has been poisoned, a model has been broken somewhere or other. As a result, you have different difficult consequences. So when we see these attacks, security, and as you see again, not much data aspect I'm talking about. I'm talking about security of the device, security of the system, and so on. So plenty of problems are there. Okay, and these perspectives, okay, other community like data science or communication, they won't comprehend. Okay, and this is our hardware background, system background that makes us comprehend these, like reverse engineering problem, then power analysis, timing analysis, where you don't hack the cryptography, we hack the system. So all these can be done and many more. Okay, and these are serious problems as compared to software, whatever problems we're seeing. And people have tried. This is like I bought this picture from Princeton's one paper. Okay, they have kind of summarized a lot of different threads and different solutions, and a lot of things are available. Okay, and but still that problem is not well solved because of a lot of overhead and so on are there. Okay, and so people have tried solutions. As I said, a lot of things going on. This is summary of maybe last 20-30 years of research going on. Okay, and going back to the details of the NFC and RFID like that, and sensors and so on, whatever components are typically involved in IoT and CPS is a very good idea. And this is one idea how we can make NFC secure. This is some information here, how we can make RFID. RFID plentifully used in agriculture domain, and it has also applications in many supply chain management and healthcare domain and so on. And this is one important, I think, and I'm not seeing many papers dealing with that, which is firmware. Okay, every embedded device or anything you take, okay, even a smartphone, even printers everywhere, or obviously the car, all the issues, that is electronic control unit of car, which are hundreds of them in one car. Okay, they have firmwares. Okay, and hardware, firmware, the difference. Firmware one can update time to time, if not that often, but time to time. And if I use, let's say, this Fitbit like device, okay, I see in few months definitely there is a firmware update. So using that firmware update, you can really disable a device. If, I mean, that is how you can really make the device complete dysfunctional. So how do we ensure the firmware is good? And this is a problem actually. I don't know how many of you heard of the term called jailbreak. Okay, jailbreak, that means actually compared to, let us say, international phone. This I use international phone because I am aware of the problem. But a lot of people buy, for example, US edition of the phone, which is the same hardware but with a firmware that is tying up the phone with the carrier. And a lot of people, what they do, they go to the mall and they pay, let's say, $25 and so on. They jailbreak the system, and that means they are essentially hacking the firmware. As a result, from that onwards, okay, the system is vulnerable to all the security problems. So that's why firmware security, I'm not seeing many paper, but I'm sure people might be working, and anybody interested to look at this problem is a very good problem to work on. Okay, that because firmware is part of every electronics, whether you take a smartphone, take a printer, take a TV, or take any electronic control unit of the cars, and all these, they are some way or other manufacturer or the company that is, let's say, in a phone carrier is one company, phone manufacturer another company, and they have agreement what they want to control and so on. All these are based on firmware, so this is a good problem to work. Anyway, and this is interesting. We store data. At the end, we are doing computation on the data. Hardware, software are doing the computation. So data storage is important. Okay, and we have been all the hardware, right, BitLocker kind of mechanism, but how that scenario will change with more depends on cloud is important problem. Again, I don't do, but this is just to, but this is one embedded memory security problem, is a reasonable problem. I've seen some papers, and this we did several years ago. That's a reasonable problem to work on. But I'm not doing the bottom-up thinking nowadays. I'm trying to do top-down, where I'm thinking agriculture application, healthcare application, then transportation application, like that. And then I'm doing top-down. As a result, I have not got opportunity to work on this. But if somebody wants to think in a bottom-up, that means memory is needed everywhere where it can fit in, then one can work on this. It's a reasonable area to work on. This is how I'm seeing the situation. This is I borrowed this slide from Princeton paper that is they did, and this is one of the earliest paper we can say whether this is it's a very simple conference paper, but this got a lot of attention. Okay, and what I have heard that they could hack the specific healthcare device like insulin pump with different methods, and then they presented some solutions. But this got a lot of attention from FDA and so on, which resulted into giving warning to the user that your medical device can be hacked. And in this process, it was again found a lot of things like other medical devices like pacemaker and so on are connected to internet, which users were not aware. Imagine pacemaker, somebody having serious health problem as a result, heart is weak, obviously, pacemaker is there, and that user did not know that pacemaker is connected to the internet. Okay, and that kind of problem, and having security, do security of that is very challenging. Okay, because pacemakers, insulin pumps, they do not have computational capability to run a encryption kind of software. That is the problem. And if you see, like I'll show some slide eventually, like pacemaker like devices, okay, they are quite energy constant. One pacemaker is roughly 8 years lifetime in terms of battery. Okay, anyway, so there are a lot of problems of the solutions, and we have listed many of them in a paper we wrote. And if I compare IT versus IoT, okay, IT security cannot be easily translated because IoT devices are quite diverse. Billions of IoT devices, each one may be unique. And then they have severe constraints in terms of the computational capability, in terms of power. This is one example, let us say, pacemaker here or insulin pump. We need to have solutions which are not battery hungry, okay, and which are safe, and which again will not add to size or weight of the device. This is the key slide, slide number 53. What the tell, if we have a pacemaker, its battery life with 10 years, doesn't have computational power. If it's a neurotransmitter, that's a both are implantable, both have to be safe, both have to have battery life which is as long as possible, not just 10 years, why not 20 years? So they are again energy harvesting, so on. Those who are interested to work and probably can work. Okay, I'm not seeing many. And what I was talking to some people, what kind of energy harvester potentially can be there, and some people are saying with the inductive kind of charging of these devices are still difficult because energy has to move through the bone, muscle, and skin. Okay, so what potentially can charge when something is implanted, it's not just what kind of battery and other things are there. In addition to whether energy can penetrate the what is that bone, skin, and so on. Those are important points to notice. And again, also even communication point of view, what kind of communication is going through the body is again another different type of problem. And there are, as of now, I don't see so many Wi-Fi, 5G, 4G, all these, they have different standards and so on. I'm not seeing standards which are for body communication, okay, because there are a lot of implantable, there are a lot of wearables. So eventually it will happen, but here security doing all these is a very, very difficult problem because they do not have computational capability, they do not have also the battery. Okay, anyway, so this I was saying, okay, lattice constant problem in the car, very interesting problem to work on. This is a problem which is energy and lattice constant because this is range limited, and as well as the solutions has to be much faster and variety of signals it's processing. Energy point, smart grid security somebody wants to work on. Okay, it's a certain extent to the embedded devices built inside that are energy constant, but overall grid doesn't have energy problem. Here rather, it's always connected, and then it's as a result of being always connected, this has much more vulnerability as compared to a smartphone and so on. That is the problem there. Then people try to attack using software, hardware. Software remotely typically attack and so on, but hardware attack, which is like having a Trojan horse and so on, are much more because you cannot find those, many identify those. Okay, and that's why these problems through hardware is much more difficult. Okay, and similarly, solutions hardware software based can be done. Okay, and this is a further difficult problem that which I will see. Then a little bit information, what is then security by design? What we learned is hardware cannot solve everything. Software also cannot solve everything. Hardware problems are much more difficult. Software, you can update things, okay, and you can be doing remote and so on. So anyway, so a lot of different observation, okay, but at the end, from a system and device point of view, we have to optimize this, okay, how to have security, which doesn't have a lot more impact on energy, which is cheap, okay, and which doesn't have latency overhead, which does not affect the AI and other operations, as well as safety, safe. Okay, all these are different constraints. They have to be optimized depending on the application in the city of village scenario. Okay, and then what can be done? Okay, and then when we are thinking to have these optimization in this multi-axis, what you can say framework. Okay, then like I was working on and secure digital camera and so on that I did in 2004 and so on, roughly now more or less 2 decades before. So those actually built-in security is the way to go. I've been thinking since then, and then I found out in 1995 when European law that is GPDR came. Okay, people were paying attention to what is called privacy by design. Okay, and then I thought of, okay, why this hardware assisted security, whatever I'm calling, is essentially something similar to that, but that's not privacy, that's security. And then that time I was contacted by some people who the person who invented this privacy by design to, okay, whether we can do something. Then we wrote an article and we coined the security by design from those days, so, from that time. So that is how roughly we can say around 2019, 2020, we started basically this community, security by design, sorry, privacy by design community. And then my thought of hardware assisted security, those we kind of reworded, we can say, and security by design or secure by design. This is a verb, this is a noun. I like security by design, but some people use secure by design as a verb, which is okay. Anyway, the idea here is how to have features, hardware mostly, because hardware can have low overhead, okay, and not software, but you can take help of software, okay, or software taking help of hardware, but hardware is key, okay. And what is important is to have built-in mechanisms, okay, so that you don't do things first, then you do retrofitting. No, you do right from your design phase. Okay, what is the problem of retrofitting? Let's say worldwide, a lot of smart cities, including Odisha, Bhubaneswar, smart city is not a greenfield smart city. Okay, whereas what is that? Chhattisgarh, Nairapur is a greenfield smart city. What is the difference there? And most of the situation in the world, city existed 100,000 years ago, and then additional things were added to make smart city. That is a retrofitting approach. That is, you do your system, do your device, then worry about security. That's retrofitting. But when right from step 0, okay, I need to have some features so that it can be used as a security tool. That is security by design. Okay, so retrofitting should not be there, rather from step 0 of design phase. That's the idea. Okay, and there are 7 basically principles of security by design, which like in the article I wrote, and this further can be expanded, and I'll be doing some point or other these things, but it's these are proactive and not reactive. Okay, that is one important thing. And what is for engineers, for like us, is important is a fully functional, not positive sum, not zero sum. What is the meaning of that? Is to have the security without compromising on its performance capability and security capability. That is the important. Okay, so it is not like, okay, you have security, so as a result you pay the price. That's not how it has to solve. We have to solve going back to the drawing board and then solve it. So bare minimal, we have to optimize. If not, this access, which is complex, just the way classic old time we used to do, area, delay, latency, like that you can think is cybersecurity, energy, and intelligence. Okay, these 3 we have to optimize, and this intelligence means more computational, potentially more hardware, energy. We do not want battery to be drained as fast as possible. At the same time, cybersecurity feature has to be added. So these 3 axes optimizing from the design phase has to be done. Okay, anyway, so that's this definition there, hardware, assisted security, and so on. We can read a lot of alternatives. Okay, and here the slide that we have been really trying is the POF. Okay, that is use of POF because of these 3 important aspects: power efficient, possibility, reliability, tamper proof. Okay, as a result, we are using POP, and a lot of things are there, and in the interest of time. But this philosophy I've been exploring, as I said, my first paper on this with that philosophy, that is low power watermark chip design 2006 and so on. Then this camera long time ago, that again, like we're talking a decade of time. All these things are done, and here student like 2019, this is integrating POP in Internet Medical Things framework we did, and we demonstrated, but I was not happy with the result, but we have some publication. I didn't like that. This is 200 microwatt per publication consumption, but this is a beginning to integrate things. Okay, then with NIT Jaipur, we developed this secure iGlue. iGlue is already we have filed the patent. That's a glucometer that's taking a blood sample, without taking blood sample, giving glucose results, but at the same time, whether we can have a insulin pump, and this is a closed loop security system, secured system. So that is what the idea. And again, we have complete validation. This is a very interesting idea that we did. Okay, that is how to speed up blockchain in terms of the scalability and latency of operation, and at the same time providing much better security. Blockchain is not secure. In fact, Bitcoin has been hacked multiple times. Okay. Anyway, so we did that. We called this POP chain, and it has got a lot of attention. I'm seeing a lot of people basically doing works based on this idea. And then the idea here is to have a security along with the blockchain, rather double layer security and so on. And we have a lot of variants, POP chain 1, 2, 3, in multiple years we have developed. Okay. And it's a very fundamental work. We went to the best drawing board and then fixed a lot of things, and I can skip in the interest of time. And the results, this is POPChain 2 results and POPChain 3 different actually. Yeah, this is a very interesting slide. We started in 2020, let us say, and then we have this variant in between others borrowed those ideas and did some work. And we have now a POPChain 3 version where we are experimenting with next generation blockchain, you can call is a Tangle. Tangle is a separate, different blockchain compared to whatever available as a blockchain from various public and private blockchains. But we are exploring the last one we did, POPChain 3, we called with the Tangle. It's a different data, basically a distributed ledger, not just a blockchain. Anyways, and this amazing security point of view, we are very pleased. Things are working excellent for the POF and other things we have done. Okay, anyway, so these are some example. I'll scroll through in the interest of time. A lot of things if you're interested. All these actually you can do as a research. Okay, these are still unsolved problems. This is what Professor K came and I with the student who graduated, Ram, we did this very interesting idea, and then I helped to again package it, polish it, and amazing work. And this as compared to our own PMSEC paper, which is 200 microwatt, this is 22 microwatt, but still I'll be very happy if the power consumption reduces further. This just got accepted a few days ago in ACM JTC. So this again similar range of power. This is providing one type of security. This is I think a ring oscillator POF, and then this is a analog Trojan resilience design. Okay, yeah, a lot of things, and this is what NIT. This is IIIT in Raipur people did. One PhD student. So here she's trying to do since integrated next generation things. That I coined that term for them, I think, and for NIT Rourkela, eternal thing, that term we coined. And so here again harvesting and so on. So as what I've been telling, that is energy aspects, cybersecurity and intelligence aspect. Those three have to be optimized. So they have to go together to have meaningful solutions. Okay. So then the long-term vision I was saying collaborative computing one can do, but I'll skip the interest of time. And one student, she's looking at this problem. That is when you have this kind of computing platform that is horizontal collaboration, vertical collaboration of different edge servers, how things can be secured. So this is one paper we use TPM here, and we have reasonable solution as compared to existing ones. Okay, very reduced overhead, And here we are further trying to improve the result as compared to TPM. We used arbiter pop and so on. Results are far better. So these things are there, and this element POF is very important as we discussed. And in the interest of time, what I would just say, POF is something that is unique in terms of its challenge response pair. So if it is different challenge, different responses, okay, and if you use same input for the different POFs, you will get different responses as well. So, and important point is POF is not encryption. Okay, and in fact, I'm intentionally trying to do not encryption. Okay, because that is what every software, every communication people. What is security? Just extend the length of the key. 256-bit key, 128 long time ago, now to be like that. Okay, so if it is encryption and your security is by extending the key length, we do not want to do that security solution. Why? They will definitely fail. It's a matter of time. If this key-based encryption definitely will fail. And if the quantum computers come, like even 1028-bit encryption key is a matter of time. That is why I'm not interested to do encryption kind of solution. What is other than encryption solution we are doing? Okay, and I remember during my master's in 97, 99, I did watermarking that made me quite popular. In fact, I remember I proudly tell I'm one of the few people coming from India who did not have to go through H1 visa process, okay, because my master's helped me to get green card straight away. And when I was a PhD student, I did a self-petition. I got green card in a couple of weeks because of master's work. So watermarking was that popular, and a lot of big schools, citations and so on. So they wrote later how they did. So I thought right from those days, not encryption, do something else. So I did watermarking, and now I'm thinking again, not encryption, do something else. So I'm doing POF. Okay, and if you see POF based, we have done quite a bit of work. You can see my website, and this one also what we did a TPM based. I was saying that another load balancing and so on, TPM based. So these are hardware modules, okay, not necessarily the classic things. So anyway, a lot more details are there, and as I said, we can discuss. So all these slides have a lot of information. Please feel free to read. Anybody who is doing, including my student, I have told, okay, we are talking about POF. Why POF is not greatly popular? There must be a reason. So I then provided basically, yes, POF we are doing, but we have to be aware of these problems. We have to fix those. And I called one problem I've given to my current student, Vishnu. He's 4 semester ago he joined, and he has several publications now, but this problem I want him to solve. What I call them is Dr. Dilemma problem. That means here we are saying POF, we integrate POFs in devices, we integrate POF in edge devices. These are end device, these are edge devices, and somebody with some doctor did all this mechanism. Then this patient, okay, is traveling to outside country or even outside state from one state to another. Then he or she has an emergency. Then doctor in that emergency scenario, that's why this is Doctor 2, wants to access to these devices. Okay, and whether this Doctor 2 will have access, probably not. So this is that means you want to make your pacemaker very secure, but then you are creating a health crisis. That is, this doctor, second doctor, may not be able to access. So how do you solve this problem so that a patient which has POF in the pacemaker, in the insulin pump like thing, or neurotrans, whatever, implantable variables, have those POFs and still travels, and still the new doctors have access to this information, how they can access for different medical emergency point of view. So that is why this is a very difficult problem, and anybody interested, look for it. And as I said, my students, and for one problem, a lot of solutions can be done, nothing wrong if multiple people are trying. And in fact, I remember I was telling Askan that so many people in your group are working on POF. Why somebody is not doing much bigger implementation? For example, doing encryption engine based on POF, let's say AES, whatever, or all these different encryption algorithms, or even do other things using POF full blown. POF right now, the way people are using, it's used as a number generator, okay, essentially. Okay, but whether we can make a full-blown encryption using POP, I'm not seeing anybody publishing. Or I've been again telling this student who started working recently that I want to see a POP used for a full-blown encryption, also a POP used to make a TPM. And I will call that keyless TPM. That's the word I'll call, because key will not be stored anywhere. Keyless TPM using POP. I want to do those. And I'm not seeing many publications, means it's difficult. We need to work on it. So this doctor dilemma and other example I gave, and I'll be more than happy to share more ideas, because I don't mind more people are working on the same problem, because that is how science advances. Okay, anyway, this is another big important problem. Whether we have been doing nanoscale means process variation our design. We want to reduce the process variation. But in the POP, process variation is used to generate randomness. Those are again conflicting objectives. Probably a well-designed POP will have a hardware reliability problem. Or if we designed well a hardware that doesn't have process variation, then that cannot be used as a POP. So these two again conflicting, and people, those are analog domain working design expert and so on, they have to look at this. How variability our design versus needing the variability for POP, okay, maybe you call it security our design, those are compatible. Okay, anyway, that is a challenge. And how do we build a POP? Shall we go to always analog design? Right now we are demonstrating through POP, and it's very good. Again, KKM group have done eternal thing. Those hardware, they really went to the design and did those chips. But even in US, okay, we feel the time spent in fabricating the chip is quite a bit, and we have so many requirements and so on. So hardware research in general has suffered in many, including US, and then it's that's why it is very, very encouraging how KKM group has done so many hardware designs and built, that means fabricated the chip. But as a shortcut, as an alternative, most of the people across the planet, POP, they are validating using FPGAs. Okay, and many cases because of this reason, that is, it's a already variability aware design. That means we want to reduce the variability. That means as a result, that is how the classic design style. Variability is a problem, so reduce the variability. That is what we have been doing. But now we are talking about how to have variability so that we can use the hardware as a POP. These are two contradictory, and because of this problem, whether a good POP we can have is a big question. Okay, anyway, so a lot of POP has problem, we can read further if you want to, and a lot of things, but now technical part is more or less we can wind up. But this few things again, a lot of slides I skipped. Okay, and feel free to read and let me know if you have further question by email or anything. But these few slides I just want to go over with you real quick, because this I'm seeing a lot of people need to learn. Okay, first question, where we need to publish? Okay, whether we can publish in magazine, transaction letter, or proceeding, conference proceeding. This is a very important question. Many people, for example, in India, it used to be a requirement. Right now, as I hear, UGC chairman says the requirement of having 2 SCI journals is waived from this year or so. But classic thinking is you need to have a lot of journal paper to graduate, have a very good PhD. This is what I tell my students. So that is, it's not just a PhD, you have to do a very good PhD. Why? The answer here is very simple for our students here, to avoid postdoc. It's additional 2-4 years time, waste of money, waste of time. You need to earn. Okay, that is one motivation. Another motivation is how you, in US context, India and other people, they have to get their green card or permanent residency. Otherwise, you'll be going through visa, this and that, which is a lot of time. So it is right, doing a very good PhD is important, not just PhD. And journal paper as a result has a role to play. But what is important? Yes, we want to hit journal paper, but do not hit the target straight away. You have a conference paper, you present those ideas, this and that. Then based on that, you write the journal, you have much higher chance, because you are claiming this journal paper is based on conference paper. That is how the big picture works. And which one, how you sell, a lot of details are there. And again, we can discuss further later on. Okay. And magazine writing, a lot of people will think magazine writing is easy. Answer is no. Magazine writing is difficult. The reason being the language has to be used simple. We are meaning very comfortable in implementing our technical ideas, writing papers on that, because we are familiar with the technicalities of what we do. But magazine needs broad scope, needs big picture of thinking, and that needs experience. I've written a lot of magazine articles. In fact, one of my best cited magazine article is IEEE Potential article, which I did as a course project. I remember when I was a student in 2003, then I published that in 2006 and so on. It is very well cited. Like there are many magazines I've written, maybe 50 of them, but I know, and Smart Cities article that I wrote in 2016, that has probably close to 1,000 citation in itself. Okay, so I know how much effort is involved. So as a PhD student, do not work on magazine articles. PhD students should work on conference papers, then should work on making them a journal paper. Then once you have 3-5 years of research knowledge, then probably you want to write magazine articles and so on. But magazine is not for early researchers. Okay, even though people think it's simple, it is not. Okay, then journals, strong novelty needed, and what is important, and that's why when some students are working with me, okay, like whether Shashwat worked or Iskant worked or right now Pragajit or whoever is working, I'm looking at every details. What is important is the manuscript needs to survive multiple iterations of the review process. Okay, so reviewers are very picky, and I tell very simplistically, don't think you're happy with your paper means reviewer is waiting to accept it. Reviewers are waiting to reject the paper. Okay, so any small problem can be a problem for you. 3 small problem can be considered as equivalent of big problem. Paper can be thrown out. That's why we need to keep in mind every small or big are important problems, important issues need to be fixed before reviewer finds them. Okay, so reviews take time. It need to be it should survive multiple iterations of review. Novelty no matter has to be very strong. At the same time, the presentation do matter. Conference is very important for one reason, that is quick dissemination, and for other reason, networking purposes. Okay, so and how do we then go from conference to journal or journal to conference? There are ways, and that comes by experience. That is how your PhD mentor or collaborator. I've been helping a lot of people worldwide. How you make so that things are much reasonable, faster, okay, compared to others, and higher chance of acceptance. Okay, somebody can ask, this is very interesting. Shall I target journal transactions directly without a conference paper of the work? Answer is no, it's not a good idea. You can do, nothing stops, okay, and it's perfectly fine. But then you are not, what you can say, creating confidence on the reviewer who reviews it. Okay, what is substance? Why did you come to journal straight away? Okay, how do you extend? A lot of ways, and again, experience comes. Okay, from conference, how do you extend? A lot of information I have. Then conference journal is reasonable and people do. Journal to conference, can you do? Answer, probably less common, but I know ways to do. Okay, that means you first, if you want to do fast journal, because some students want to graduate and so on, whatever reason. Okay, and I can really sense that was in fact some way my what you can say capability when even I was a master student. My first paper I published or wrote rather 99, and that was the first paper, which is again very well cited as a multimedia. Then my second paper was IEEE multimedia when I was a master student. From those days, so somehow I was thinking, okay, this paper will sell this conference, that paper will sell this journal. I can tell by seeing the paper. Even right now, something that not just came by 20 years experience, but it was there somehow I was able to do. So that is why like I have developed methods. Suppose I discourage people to go to journal straight away, but suppose some student goes for whatever reason, and then we want to do a conference. Why we do conference? Because we want to meet people. When you are at a conference, you may meet people who may be a potential reviewer of your papers. So he will have positive impression. So go to conference, but do a good job. Don't take conference lightly. Okay, people are watching. So we have to do good job in conference presentation, and a lot more we can discuss in that direction. Okay, a lot of people do not suggest reviewer names when they submit a manuscript. That's a bad idea. If you submit some reviewer, suggested reviewer, and they are reasonable, then your review results may come much faster. Okay, so that is again another interesting thing. How important is open access publishing? Is very important because that is a trend. But and at a personal level, if I'm given a chance, I don't like open access publishing, but we have done many. Okay, but India context, what is more important, what I have heard is the SCI index for the PhD, which may or may not be open access, and a lot more. Again, these are very lot of different things that I'm discussing too. But you can further read and send me emails if you want to know more details. Okay, and here is a very interesting question, that is journal papers take long time. Should I only publish in conference? That answer is again no. Okay, you cannot have one extreme, that is all conference or journal. You have to have the balanced, and conferences have their own importance as so as journals. Okay, then here this is a very important. Reviewing is taking way lot time. Okay, should I submit multiple journals, multiple conferences at the same time, same manuscript? The answer is absolutely no. Okay, multiple submissions are considered bad practices. Okay, so not a good idea. You have to only one place. And again, as I said, a lot more details at the read. Let me know if you have other questions. Okay, then another, I can publish in journals. Why should I bother for conferences? Okay, I don't want travel. Okay, that answer is you should go to conferences. It allows networking. You are doing a PhD. It's the advanced degree. You need to have command over that subject. You need to feel confident doing what you're doing. You need to feel good in doing what you're doing. So conferences give that platform. In fact, when Oskanda is introducing, right, I've been going to OCIT, which is in Odisha, Bhubaneswar, since 1998. Okay, and ISS we started, and now 8 years. IS VLSI help, it's already 20 something years. Like that, many conferences. So what is the point here is conferences have their own importance. It's a good idea to go and to showcase your results. Okay. So does formatting and look matter? Answer is absolutely yes. Okay. Keep in mind, fast impression lasts long. If a reviewer doesn't like to see your paper, he will not see technical details. So your rejection is quick rejection is rather it will be the result. Okay. Anyway, many more things are there, as I said. How important is author ordering in a publication? Okay, that varies. Okay, but in our discipline, computer science, computer engineering, author ordering is not that much important. But in some other medical and so on, it seems there are a lot of authors and author ordering matters, but it has no matter in our computer science, computer engineering discipline that we work with. Okay, social media for researchers, I think I've heard. Okay. Why should I spend time as a reviewer? One should spend time. The reason is you are researcher. You are not a undergraduate student learning from textbook. If your research learning happens from textbook, it is not probably novel research. When a material appears in textbook, it is outdated material. So a lot of research happened, a lot of conference paper, a lot of journal paper, then one theme developed, one theme evolved, then only book is written. Okay, and I'm not saying the books a lot of what you can say papers stitched together like chapter writing. No, I don't like those kind of books. I like authored books. That means a whole book written by somebody. That means that area has evolved quite a bit. A lot of materials are there. Then book is written. So that's why, as a PhD student, as a researcher, if you are learning from book, probably you are not doing novel research. That is how I will comprehend. So anyway, so good idea to be reviewer to learn. Good idea to be a reviewer to comprehend the state of art. Okay, very fast and be a part of professional community. Okay. What are the best practices of publishing? No definite answer. Okay, a lot of things are there, and you can see what you want to do. This is a very important question. Okay, and this I will leave it for the time being because all of you are early researchers. Okay, and in the conclusion, we learned quite a bit of all these things, CPS, IoT, and so on. And we now know what is security by design, and one example of security by design, hardware assisted security. which is essentially advocating hardware design modification right at every phase of the design. Okay, a lot of feature research. You can think from the different smart system point of view, or you can bottom up thinking you can do. But I always recommend to do top down thinking, where you are, what I tell you, are seeing the forest first, then you go to the tree. Don't see a tree and then you figure out, oh, what forest I am in. No, first you see the forest, then you go to the tree. That is a simple way of thinking. And then that top-down thinking will make you look confident, will make you look what is the social impact of what you are doing. It's a good idea to know why you are doing what you are doing. Okay, then you have very good satisfaction. Okay, PhD is not a bunch of grades. That's for undergraduate. PhD is understanding a problem, solving the problem, which is novel. That is why you are being given at the end Doctor of Philosophy, not Doctor of Science or Doctor of Engineering. Okay, with this, a lot of materials, as I said, and a lot of things are skipped, but feel free to go through and let me know if you have questions. Right now, I'm ready to take up a few questions, or we can further discuss offline. So please feel free to unmute and ask questions, or ask your questions in the chat window. Thank you.
Sir, I have unmuted, means I have allowed mic for participant. So
Sure.
whoever wants, they can unmute themselves
Right.
and ask
And
questions.
41 people are online, I'm seeing.
Yes.
Yeah, good morning, sir. Am I audible,
Yes.
sir?
Yes.
Yes, Sandeep here, sir.
Okay, I can see.
Yeah. Sir, you discussed about that doctor's dilemma problem. Sir, what did this doctor one did so that doctor two is not able to access the things?
Okay,
Can we
very
just
good
elaborate on
question.
that?
So essentially, Doctor One has a setup of two POPs. That means, let us say, I'm going to a doctor, okay, and with my wearable, okay, and as a result, my primary care physician, okay, my personal doctor is Doctor One, let us say. So he has a POP one, and then the POP that I have in the wearables. So they are handshaking, and there is secret protocol in place. Okay, but when let's say I'm in US, then I'm gone to India. And in India, some reason I went to another doctor which may not have the POF one. Okay, which is with Doctor One. Then this POF 2 and Doctor 2, how they can get access to the original whatever hardware and the corresponding protocol, that is still a very difficult problem, because POF is changing. So now instead of POF 1 authenticating, POF 2 with Doctor 2 has to authenticate. Okay, so that is still I'm not seeing people solving that problem. If same POF arrangement, protocol this and that, I'm seeing whatever we have done, or other papers I'm seeing, but with different POPs authenticating the same device and so on, I'm not seeing many. So that we have to look at that detail. That's the whole point I'm telling.
Sir, I might be wrong, but sir, I mean, sir, I might be wrong.
Sure. Go ahead.
Yeah, sir,
No problem.
my question is, sir, I've read a little bit about puffs and so on and so forth. But then the thing that we talk about puffs is like they're unclonable.
Right.
Sir, so how would it happen? Like, sir, is it a solvable problem? Meaning, how POF2 will be used to authenticate POF1, because we are saying that they are unique. So
Exactly, that is the whole point.
Sir, is it a solvable problem, sir?
It may not be solvable, but if you then POP security for medical device is not effective. Do you see what I'm saying? So if we cannot solve doctor dilemma problem, that's simplistically I have put that problem. Okay, then probably POP integration in medical device is not going to work. That is the whole point. Okay, so whether it's solvable or not, we have to try. If we not solvable, then we have to declare it's not solvable. The way, for example, in algorithm, NP hard problems are there, right? NP hard, NP complete problems are there, but still we come up with ad hoc solutions of NP complete problem. And if you see, for example, all the cargo service or whatever, courier service, let us say FedEx, UPS, and so on, they all are doing some way. Even right now, Amazon travel salesman problem, what is called classic problem, which is NP complete problem. But we come up with ad hoc solutions, and we have all the supply chain management where time is managed. That means a carrier going from one place to another in optimal way, so that minimal time is used for the travel. So we acknowledge that problem is NP complete. We came up with the ad hoc solution. So that is why this problem, once we no, it is not solvable, not then we need to acknowledge and then accordingly, what you can say, come up with solution. Okay. So anyway, so this is very interesting question and we can further discuss. But this problem, whether not solvable or not, but at least couple of papers one needs to write and declare. Yes, this is a difficult cannot be solved, and as a result, we cannot only have POP-based solution in a healthcare domain. So we are having other solution POP as well as blockchain integrated. That's why that POP-chain idea we are working on, and we have we have worked on other 2-3 papers. So maybe that is a better solution, or only blockchain. And blockchain has its own set of problem. We are trying to completely revamp blockchain architecture and algorithm so that blockchain can be lightweight. That's another. Some students have worked and few are actually again working. Okay, very good question. Any other questions? Sandeep, we can talk later as well, but very interesting question.
Sure,
And
sure, sir. Sure, sir. Thank you, sir.
Anybody else? Yeah, anybody else has question also we can address right now. So I can spend few more times, few more minutes. So please let me know. Anybody has any questions? Please unmute the way Sandeep did and ask questions, or you can type in the chat window. Whoever physical there are, you can come to, right? Okay.
Sir? Sir,
Yes.
what is the future of with respect to TRNG and cryptography?
Future of the POF, right? So POF
Yes.
actually, as I said, POF for last 20 years after like Srinivas Devdas in MIT developed that element as an idea. Okay, physical analytical function. A lot of people are doing research, and we our group and KKM group and so on. But POF still, I always ask question why POF is then not the mainstream. And this slide has that answer, slide 157. Because designing a very good POF that fulfills all the characteristics it has is still a very difficult problem. And it is needing a lot of expertise, okay, like quality control expertise, analog expertise, and security expertise to do that. So that is why POF may not be magic element to solve all the type of hardware problems possible. Okay, but the philosophy that I was saying, that is the security by design or the hardware assisted solution needs POF. That is one way looking at, and then other looking at what we are doing different from encryption. Okay, in that respect, POF can play the role. And coming to your original question, whether it those other hardware, basically testability and other features that POF can do, if you think that POF can potentially give you unique random number and so on, okay, that point and what is its use in the case of different application, then you can think of whether for that specific application POF is useful or not. But POP is not, one should not think it is a magic element that will solve many problems. Okay, we can, as I said, how we are doing different for encryption is primary thinking, and how we are doing hardware modification so that there is built-in security, that is how POP is coming to picture. Other POP has a lot of difficulties, as I said, slide 157. Okay, so probably I didn't answer that direct question directly, but this is how I'm telling you, you have to think that way for your application, whether POP, assuming as a unique random number generator, whether I can use it. Okay, that way if you think, you will have that answer. Okay, thank you. Any other question? Hey.
Sir, my question is related to agricultural IoT. Sir, actually, we have data set available for Sentinel-1 and Sentinel-2 data are like landscape data are available. And sir, like we can do NDVI also, so that while the crops are growing up, it is providing different images. Now for sir, the images are different when the crops are growing because the Sentinel-1 data is providing backscatter image, and for after 15 days the images are different. So my doubt is like if we are monitoring something like for you also tell us about the cyclone monitoring. So how can we make a total system, or how can we develop a IoT so that we can use this data? Because if Sentinel is providing two type of data, sir. One is GRT image, sir. One is GRT. Another is our complex data. So one is of 1 GB, another is of almost 9 GB. So it is difficult to download, then to operate, then to find out the exact area. So it takes a lot of time. So I'm getting confused how to do all these things smoothly. Actually, I searched for automation. Now for software testing, they are using Selenium, sir. So with using this software, they are doing the automation one. By using that, we can log into a site. We can download the data. But then how to operate next? Now I'm stuck here, sir. And
Okay, very good. So that is the way I see. You can contact me later on offline. Okay, the way I see, you basically have, let us say, you said 9 GB data for something, 1 GB data for something, right? And then how do you develop model and so on, so that those models will run on certain edge device. That is what your problem, the way I understand, right? Or on some sensors.
Actually, I worked on a project. I
Right.
have downloaded Sentinel-1 data, that is of GRT image for
Right.
3 different data sets, sir, for the cyclone Fani, and it was showing me the water bodies they are developed within time, and it is showing a good result. Almost 8% of extra water bodies created within 3-4 days. And that was there for 50 more days. So, but how can I develop a system which will help us in future? Because if we overlay the optical image and the satellite image, means SAR image and the Sentinel-2 image, so it will show us the eye of the cyclone which is moving.
Right.
So we can track with that, because when there is a disaster occur, all the satellites are at the same time. Many satellites are synchronized to the same part, so we are getting a lot of data. But we don't get. Means I don't find how can I merge all this thing to make a system.
Okay, very good. So that's basically the way I understand from your question. We have to have in this context probably like 2 types of models. Okay, for example, IoT cloud complex models with a lot of data. And when we are doing that modeling and it will be IoT cloud based, we can assume that is we can use servers, okay, to do the modeling. For example, with NVIDIA graphics or APJ accelerator, okay, you can model. Okay, and then those models can be reasonably heavy duty. That's one type. Then another type of model we have to develop what we call as a tiny ML. That the term a lot of people are using, and we started using long time ago. Tiny ML means how to have light duty one model so that it will run with some edge device. Okay, in fact, the way we compare whether a student when develops a model, if it is running in a Raspberry Pi like device, then we think, okay, that's a tiny ML kind of model because it's running with very minimal horsepower of the processor. But modeling time point of view, okay, that model development may be with the cloud-based model running on the cloud, or cloud is helping to model, but you are developing tiny ML, that is lightweight ML, which will run in a Raspberry kind of computing platform. That is how 2 different computations we have to think. Okay, and then your this weather forecasting problem or other problems can be solved, which essentially needing a lot of data, but modeling wise different effort and so on. Okay, anyway, so more details we can. It's a very interesting problem. Okay, and that is what we can take up in the offline if you need specific help. If you send me, let us say, a kind of manuscript and so on, which has some certain information that how to carry forward from here to next level. Okay, I can give detailed feedback on how to do. And we have last 2 students right now, in fact, recently who defended VLSI.NITRourkela, one student. She just defended and she's joining University of Nebraska Lincoln, and she is basically the first student who did AI aspect of smart agriculture with me. Okay, and she's joining, and Fortunately, again, as I always tell, I train students such a way that they don't have to postdoc, they get direct job or direct faculty positions. And then another student who is handling storage of the data. So Alagranda handle the AI aspects of the data, a lot of agriculture data, and how do you model for different purpose. And another student is working on storage of the data with blockchain, with the distributed ledger. So that student also can help if you want to think, okay, what is alternative storage? But definitely, please feel free to send me email with this information. Then what is detail, whether it's how the paper will sell, whether you want to do a cloud-based solution or edge-based solution, so that you have a lot of novelty and you are solving the problem. So we can take up offline for the detail specific aspect of that. Okay, but as you said, we have to think whether cloud or edge-based computing platform is helpful for the training, and then what kind of model is needed so that model will run. Okay, whether it runs on a small edge device like Raspberry Pi or running on a computer with a good i9 kind of server and so on. Okay, we can think. So please feel free to email me. Okay, and I'll be there in ISS in NIT Warangal as well as OCIT in KITS Bhubaneswar. So feel free, if anybody is traveling, we can talk there as well. Okay, thank you. Thank you. Anybody else has any questions?
I think if there is no much questions, we can end the session.
Right. You can please send an email, and also as I said, I go to India in summer and December, summer and winter basically. So we can further discuss when I'm there. It's not a problem.
Thank you, sir. For
Okay, thank you all, and it was really very good opportunity to interact with all of you. Please feel free to be in touch. Okay.
Thank you, sir,
Thank you.
for joining us and giving some ideas, research as well as carry out conferences and journal.
Right.
IT.
Right.
Thank you, sir. Any?
Okay. Thank you all.
Hello, sir.
Yes.
Regarding sir, two random number generation.
Somebody Pratik, right? Probably.
What is the model? Yes. Sir, regarding the reliability and different parameters and the power and efficiency of any proposed TRNG, about Q2 TRNG or two random number generation normal approach, that is model will be used public available functions of 250 will be used for that. Regarding with that, with
Right.
any model of TRNG, AES cryptography, encryption and description process.
Right. So there are benchmarks available to test those aspects. Okay, whether the random number that you're getting is two random number or not. Okay, and actually generating random number is a very important problem. Okay, and I always tell why we cannot have very good design which is true random number, because we are using computers which are deterministic. What computer does? Computer executes the instruction in the program counter. So instruction are sequential, instruction 1, instruction 2, like that. So we have kind of more deterministic computation. That is why two random number has been challenging, and it will remain a challenge. But we have solved reasonably generated two random numbers, and there are benchmarks that test whether POP is generating or even a encryption CPU design is generating two random numbers. So I think NIST, that is US National Institute of Standard and technology and so on. Okay, NIST is able to give, I think they have benchmarks and so on.
Yes, NIST 200
Right.
will be generating different linearity and block linearity and different parameter will be using calculation of different what parameter will be used for that PUF technology.
So similar, because at the end, if you are considering POF to be used as a random generator, it needs to fulfill the same criteria as any other random generator. Okay, and whether POP can become a TRG, that is one application, and that's a very interesting problem. And I was discussing also POF is not necessarily a magic element. It has its own set of problems, but it has also its lot of promise to do solve a lot of problems. So that is why using POF as a randomized generator, using POF as an encryption mechanism, okay, those are valid research problem to work on. Okay, and like I'll be more than happy if you want to get more feedback. Okay, and as I said, I remember to Professor Swai here that so many students are working on POP. Why don't you tell a student that I want to do a POP-based TPM, I want to do a POP-based encryption design, and I have told that to my student as well. And this is very interesting application. And random generator is definitely a very interesting application to work on. Okay, and POP weather can be very interesting TRG. That is what is exactly research. Okay.
The proposed technique, yes, regarding proposed techniques, design of proposed TRNG, it is model will be with the CMOS inverter.
Right, so
topology
that is where we are stuck with
we
CMOS. Okay, so
assembled. Yes, yes. Last, sir, CMOS inverter topology with a three-phase interleaver process will be process will be used for design of proposed schematic of TRNG. Design of schematic of TRNG. I'm asking
okay.
64-bit 64-bit processor TRNG.
Right, no, we can try actually that's to try which POF is able to do a very good, whether strong POF or weak POF. Okay, what is able to give us a very good two random number generator. That itself is a research topic in addition to what topology, whether ring oscillator is doing a good job or a arbiter or a SRAM and so on. Okay, all these are very interesting. What is that will be useful to do to random. That I've seen many people have worked on that random generator using POP. Okay, that was in fact one of the earliest applications people thought of. Okay, so that's why a lot of things can be done, even though some things have been already done. Okay. Please let me know. Okay, further questions we can take offline again. Send me an email. But as I said, this is very important application. Okay, and we need to look at POP as I said, alternative encryption, but POP may not be able to solve every problem. Okay, thank you.
Thank you, sir. Thank you for your time.
Sure.
And,
Very good. And please feel free to stay offline by email and so on. We can further contribute. Okay, thank you all.
thank you.
Thank you. Very good.